Okay, over the next several YouTube videos here, I'm going to do hopefully a comprehensive summary of the chi-square comprehensive summary of the chi-square test, just to make sure that you've got a really good foundation on that. That is really the only new material of any substance that you're going to have on the final exam. So let me just make sure that we're square on the chi-square test. I've got that highlighted here on the screen. So keep in mind that the three categories of inferential stats are test of differences, test of association, and predictive modeling. Okay, and as I talked about earlier in an earlier Panopto, and as I said in class, in a way, you could consider the chi-square test of independence to be a test of differences, because we're comparing whether two proportions, three proportions, or more are equal to or different in value. But the reason why we put the chi-square test of independence under the category of a test of association is because of the contingency coefficient. It gives us a number ranging between 0 and 1 that indicates the degree of strength of the relationship between our two nominally scaled variables of interest. Okay? And the same can be said for the Pearson, as we had done previously in this semester. And sometime this week, I will get a brief memo to you on the Spearman, just so that you've got that under your belt. But it also ranges from 0 to 1 in an absolute value sense, much like the Pearson. The only difference between the Pearson and the Spearman is that with the Spearman rank order correlation, we use ordinal data, whereas with the Pearson, we're using interval or ratio data. Okay, but this mini lecture and the next couple are going to focus on the chi-square test of independence. All right. Now I'm just going to use this same data that we've worked with in class previously to reinforce the points. So what we're interested here are whether two nominal variables, in this case marital status and whether or not you drive a sports car, we're interested in whether those two variables are related to one another. We have a sample of 120. Okay, we have a sample of 120, and you can see that of the 120 people, 41 drive a sports car, 79 don't. Of the 120 people, 57 are married, 63 are not. So what we're interested in here is not whether 25% is equal to 43%. We expect our observed proportions to be different from one another. What we're interested, though, is the difference between these two observed proportions. Is the difference between them large enough to conclude that our populations, population number 1 being married people, population number 2 being single people, are the difference between these two observed proportions large enough to conclude that the proportions in our two populations are different, or is the difference between these two proportions small enough to conclude that it's only attributable to random sampling variance, and that indeed our population proportions would really be the same? That's why we do the chi-square test of independence. Okay? That's why we do the chi-square test of independence. Recall also I set up this table here artificially. I set this table up artificially. This is a spatial circumstance actually, where not only are your column proportions equal to one another, not only are your row proportions equal to one another, but the column proportions and the row proportions are all the same. Okay? I've never seen this in all the chi-square tests I've done. I've never seen this happen. Nevertheless, this is the way I set the table up. Okay? So in this instance here, our null hypothesis is that our two proportions are equal to one another. In other words, the proportion of married people who drive a sports car is equal to the proportion of single people who drive a sports car. Our null hypothesis is that those two proportions are equal. Our alternative hypothesis is that the two proportions are not equal to one another. Okay? Are not equal to one another. Okay? So let me close this mini lecture off at this point, and when I pick up next, I'll talk a little bit about this table. I'll talk a little bit about this table and how the tables relate to the graphs down here, and then we'll actually run a chi-square test. Thank you.